Good morning, students. I am Dr. Sunita Tandon from RR College, Alwar. Today I am going to deliver lecture number 18 of your unit 2 in chemical dynamics. Now, in 17th lecture, we have studied about the catalysis of unimolecular reaction and the rate of mechanism of unimolecular reaction. Now, today we will study the catalysis of bimolecular reaction. Micellin inhibited and Micellin catalyzed unimolecular reactions can be treated quantitatively by considering distribution of substrate between aqueous and micellar pseudophase. But this model fails in bimolecular reactions. In case of first order unimolecular reaction, we have studied this in case of micellar pseudophase solution. But in case of the biomolecular reactions, the distribution of substrate between aqueous and micellar pseudophase is not predictable. This model failed in case of biomolecular reactions. The reason is that it considers only distribution of one reactant between pseudophases, whereas two reactants are involved in the bimolecular reactions. The failure of the model is illustrated by the rate maxima, which increases the surfactant concentration, which is typically observed with catalyzed bimolecular reactions. This is clear from the graph. The micellar catalysis of bimolecular reaction involving ionic attack on a substrate is reduced by added salts. These salt effect depends on the nature of added counter ion and increases with their increasing hydrophobicity. Ions of like charges to the micelle have only small effect on reaction rate. The inhibition in the rate is because of ability of inert outer ion to compete with a reactive counter ion for the micelle. Secondly, rate of micellar catalyzed H-ion reaction depends not only on the total H-ion concentration but also on amount of micellar bound hydrogen ions. All quantitative kinetic treatment of micellar catalyzed reaction have assumed that the micelle can be treated easily. They were separate phase. Colloidal scheme analyzes the characteristics of the micellar catalyzed bimolecular reactions like this. Dn plus Sw with rate constant of Ks is converted into Sm. This Sm with rate constant of Km and in presence of Nm gives products. Similarly, Dn plus Sw with rate constant of Kw and Nw, it also gives products. The observed first state order constant K psi is given by the rate equation K psi is equal to K dash W plus K dash M Ks D minus CMC in close bracket upon 1 plus Ks into D minus CMC. Where KWM K dash W is equal to KWNW, K dash M is equal to KMSN and MSN is equal to NM divided by concentration of D minus CMC, where KW is written in term of molarity and that in the micelle by Km in term of mole ratio of the bound micelle N to micellized surfactant MSN. Thus rate equation can be written as K psi is equal to Kw into Nw plus Km Ks MSN D minus CMC upon 1 plus Ks D minus CMC, where K psi or F is equal to Kw Nw plus Km Ks Nf 1 plus Ks into D minus CMC. The reaction can also be written in form of F of micellar bound reagent N, or in terms of binding constant K. K2 is equal to Kw plus Km plus K2 is equal to Kw plus Km Ks Kn D minus Cmc upon 1 plus Ks D minus Cmc in bracket 1 plus Kn D minus Cmc. These equations have form similar to those which were used by Berzin et al. And Romstead and account for rate maxima of bimolecular reaction. The rate maxima is typical in micelle catalyzed bimolecular reactions. A few examples of such reaction are as follows. Reaction first, second, and third is with H ion, cyanide ions, and with bromide ions. Following reactions, these reactions are with hydrogen ions, cyanide ions, and bromide ions. Following reactions are different from these reactions of cyanide, bromide, and hydrogen ions. In these reactions, the rate constant K psi is equal to first order. Increases in reaction 1, 2, and 3, except reaction of OH ion, that is 4 and 5, with increase in concentration of surfactant. However, for OH ion, reaction K psi steadily increases with increase in surfactant concentration. Even when all the substrate is apparently bound to the micelle and under these concentrations, added hydroxide ions increases K psi contrary to predictions. It appears that such hydroxide reactions are a special case. Thank you, students. Next, we will study lecture 19 a day after tomorrow.